Last week, I posted 2 videos in my channel about several example use cases for destination NAT, which was newly introduced in UniFi Gateway. Today, let's talk about source NAT or SNAT. The first scenario is very simple. We just want to give a single device in a particular VLAN the internet access. All other devices in the same VLAN will not be able to access internet. Let's see how we can do that using SNAT. Then we will discuss, okay, you have multiple public IP addresses from your ISP, and you even have multiple WAN ports on your UniFi gateway. But how you can define a rule for a given device in your local network, its internet traffic will only go through a particular WAN port or a particular IP address. Let's see how SNAT can achieve that. Then we will talk about one-to-one NAT, and we will combine the DNAT and SNAT rule to achieve one-to-one NAT. In my lab environment, I have a UniFi Gateway UXG Pro. I have 2 WAN ports, the 2 green ones, port 1 and port 2. You can tell from the IP address shown here, they are both private network addresses. The reason is I'm running the lab environment behind my main router, so that's why even the WAN IP addresses, they are also private network IP address. But it doesn't matter. Everything I show you in this video will also work when you have real public IP addresses on your WAN ports. Let's look into the first scenario. By default, if you don't do anything, every device in your VLAN will have access to the internet. I have 2 example devices. The first one is in VLAN 10, the second one in VLAN 20. At this moment, for example, from VLAN 10, if I ping 8888, yeah, pingable, and from client 2, also pingable, right? But what if I want to achieve the effect that in VLAN 10, all other devices cannot access internet? I only want to permit this single device to have internet access. Of course, there are many ways to achieve that, for example, by using firewall rule, right? But let's see whether we can just use NAT to do that. So first, we need to disable the VLAN 10's internet access. Go to settings, routing, NAT. You can see the global NAT settings. By default, it's active, which means all the VLANs, they will have the NAT rules applied. So they will have internet access because the NAT help them to have the public IP addresses when they want to have internet access. But if I disable alter, I can choose custom, and let me say I want to exclude VLAN 10 from accessing internet. Apply changes. At this moment, let me try the same ping command from the VLAN 10 device again. You can see it's not pingable anymore. But from the VLAN 20 machine, it's still pingable. We achieve the effect that every device from VLAN 10, they don't have access to internet. So now let's see how we can enable this client 1. I go to NAT, and for SNAT, I already created this allow client 1 to access internet rule. Let's look into the details. I simply included all the protocol because we are talking about internet access. And for interface, I'm choosing primary WAN port. So I want to stress here about interface. If you watched my previous videos for DNAT, you can see for DNAT rules, they also have the seemingly same interface setting. But Ubiquiti should have done a better job here because for DNAT, the interface is the in interface. But for SNAT, the interface is the out interface. Only when the traffic is exiting the interface, your rule will be applied for SNAT. The interface here is out interface. Okay? So then for translated IP address, because I chose primary WAN port, by default, the translated IP address is the main IP address for the primary WAN port. And then because we are talking about SNAT, I want to specify a source. So in my case, I want to enable this device once internet access. So for source, I specify this VLAN 10 IP address for this device. That's it. That's the simple SNAT rule, and it's already enabled. So we can quickly see the effect from the client 1 machine, right? Let me ping 8888. Now it's pingable. So let's go to the UniFi gateway. Let's see in backend how this particular SNAT rule is implemented. Let me SSH into the UXG Pro. I'm in. Let me run this command. IP tables, I only want to show the NAT table, and I want to show the details. I only want to see the SNAT rule. You can see there's one and only one SNAT rule created, or is for protocol. The in interface is any, out interface is eth0. eth0 is the primary one part in my case. So you can see even though here for interface, you see primary one part is implemented as the out interface, right? Then the source is this particular VLAN 10 client machine, and the destination is anywhere, just like what we specified on the UI. And then this part is for the translation part. It will be translated to the primary one's IP address. If you are interested in how the internal translation is working from part to part, let me run the TCP dump for any interfaces. Then I only want to see ICMP, which is for ping. Okay, you can see even though now I'm not really testing anything, there are a lot of ping traffics. It's simply because the gateway itself is doing the connectivity and the network speed testing. So that's why you can see many ICMP traffics already. Just ignore them from this client 1 machine. This time let me ping 9999. Okay, then let me stop capturing. Let's try to find our internal traffic. Okay, starting from this line. See the interface is at 3.10, which is for VLAN 10. And the source is the client 1 machine, and the destination is 9999, and it is ICMP, right? This one is easy, and move on. See, now it's BR10. BR10 is the bridge for VLAN 10. It's the same source IP address, the same destination. Let me pause here. Let's talk about the BR10. If you watched my previous video about DNAT, you may remember there was a bug in the Ubiquiti's implementation. For the DNAT case, the system used a BR something interface for DNAT rule, but the interface itself was not really generated. So that's why in that particular video, that DNAT rule didn't work because of the bug. But here you can see the BR10 is in action. I assume this time the bug is gone, but let's confirm that. Let me run a command, brctl bridge control, then show this bridge BR10. Okay, now this time it's working. You can see the BR10 is based on the two interfaces, S2.10 and S3.10. These two, the S2 and S3, they are the two LAN ports, and the .10 is for VLAN 10. So this makes sense, right? Okay, this is just a side note. Let's go back to the traffic. We just talked about the second line. It's understandable. Then move on to the third one. You can see now the interface is eth0, which is the primary one part. See what's changed? This time the source is the one part IP address. It's not the original client's IP address anymore. Why is that? Because of our SNAT rule. Okay, if the interface is primary one part, if the direction is out, we will translate the private IP address to the public IP address of the primary one part. That's exactly what you see here in the third line, right? Then in the fourth line is the reply from 9999, and then going back to bridge 10. See, in this line, the IP address is back to the private IP address for client 1. Why is that? It's because of the SNAT rule again. For the SNAT rule, it will not only translate the source IP address to the translated IP address when the traffic is exiting the interface, it will also translate the IP address from the translated IP address back to source IP address if the traffic is the reply. So what you see here in the fourth line is exactly that case. It's the translation for the reply frame. Okay, so then all the remaining traffics, they are just normal VLAN traffic, so we don't need to explain the details. Okay, basically this ends this first scenario. Is pretty straightforward and very simple to understand. Let's move on to the second scenario. So in this scenario, I have 6 IP addresses for the test environment. This is the primary WAN parse configuration. Under the IPv4 configuration, I set it to static IP and then give it the main IP address here, 3 additional IP addresses. For the primary WAN part, I have 4 IP addresses. Then similar situation for the second WAN part. I have this as main IP address and a additional IP address. So I have totally 2 IP addresses for the secondary WAN part. However, you can see for the current load balancing setting, I have the failover only setting, which means even though I have 6 IP addresses on the WAN part, by default, all the internet traffics going out of the gateway will use the primary WAN part's main IP address, which means the first one, the .2.191. We can easily validate that by using the TCP dump in the UniFi gateway. So here, let me run TCP dump against all interfaces, but I'm only interested in part 80. Then from the client 2 machine, it is in VLAN 20. Let me use wget to visit this HTTP website. By the way, this website will not redirect the traffic to the HTTPS. So it will use port 80, which will work with TCP dump. Because just to simplify it, I only want to show you the port 80 traffic, right? So that's why I'm using this particular website. Let me run it. Okay, successful. And in the left side, something's captured. Let's simply check what IP address is used when the traffic is exiting the WAN part. So see here, let's see what's the WAN part. S0, which is the primary WAN part, right? What's the IP address used? It is the .2.191. You can see from the diagram, it is the main IP address of the primary WAN part, right? No matter how many times I try, you will see the same result. If I don't do anything, all of my other IP addresses will be wasted. So in this scenario, let me have 2 different tries. First time, let me use SNAT rule to achieve the effect that for the device 2, it only use the primary WAN part and only use the second IP address, this green one, to access internet. The second try, I wanted to only use the secondary part and this red IP address to access internet. Let's look into the SNAT rule, which I already defined. See, the interface is primary WAN part. It makes sense, right? Because the first try is the green IP address, which belongs to the primary WAN part. Of course, for the translated IP address, I cannot use the main one, but in the dropdown, you don't need to manually input it. You can simply select it because all the 4 IP addresses, they are part of the WAN part configuration, right? I simply choose the particular IP address. And then for source IP address, I specify this VLAN 20 device IP address. Okay, that's how simple it is. It's already active. Now let's validate it. So in the same way, in the UniFi gateway, let me run TCP dump. Then from the client 2, let me visit the same web server. Then let's examine the captured traffic. See, this one is from the S3.20, which is for VLAN 20. Source IP address is the client 2, right? And then the next one is BR20, no surprise. And then the third line is for the primary WAN part, and the direction is out. And this time the IP address is this particular one. See, it is the .2.192, which is the green IP address. Why we have this translation? Because of the SNAT rule, right? That works. And then all the remaining ones, they are very straightforward. I don't want to waste your time anymore. So you can see the first try is successful and it's not difficult to understand, right? Then let's try the second one, which is I wanted to use the secondary WAN part. So let me simply change this existing SNAT rule. Let me say translate client 2 to use IP number 6. See the interface? This time let me choose 1.2 because I wanted to use secondary WAN part, right? Here for the interface, I want to choose 1.2. And then for IP address, use the 182. Then for source IP address, I don't want to change it. Let me apply changes. Then from the UniFi gateway, let me run the same TCP dump command. Now from the client 2 machine, try to visit the same website. Okay, it's successful. Let's see what happened this time. See this line? It started from the VLAN 20, no problem. See the next one is BR20, again no problem. And the third line, we have a problem. The third line is for the primary WAN part. It's not what we want, right? And then the IP address, see what's the IP address? It's .2.191. What's .2.191? If we check the diagram, you can see it's the main IP address of the primary WAN part. This traffic dump proves our SNAT doesn't work because the system is still using the primary WAN part, the main IP address, instead of what we want, which is the secondary WAN part and the IP number 6, right? The SNAT rule didn't work. And why it didn't work? It's very simple, because our current internet setting is we set it to the failover only, which means the system will not even try the secondary WAN part. Even though our SNAT rule is defined, it will be never effective because the traffic will never exit secondary WAN part. But how we can make it work? Let me go to this SNAT rule. So here for interface, instead of saying secondary WAN part, let me change it to primary WAN part. But for the translated IP address, let me manually input the IP address. Let me apply changes. Then let me run the TCP dump in gateway from the client 2 machine. Let me visit the same website. This time let's examine the traffic. Okay. The first one from VLAN 20, no problem. The second line from the bridge 20, no problem. The third line is the primary WAN part. The direction is out, no problem. And this time something's different. See the IP address is the manual IP address we specified in the SNAT rule. So this is kind of weird packet because technically, this IP address is not really assigned to S0, and the packet still sent out from the primary WAN part. And see the followed traffic is direction is in, but this time the port number is S1, which is the secondary WAN part. The packet was sent out from the primary WAN part using this IP address, but it is received by using the secondary WAN part by using the same IP address. Let me explain what really happened. So this SNAT rule kind of works in my lab environment simply because my lab is behind a single main router. So my router accepts all the 6 IP addresses, no matter which part the traffic is from. If you try the similar way by using real public internet IP addresses, it may not work for the secondary WAN part case. It all depends on how you get the public IP address, whether from the same ISP, it may not work. But the first try, by using the primary WAN part, it should always work. Okay, now let's move on to the third scenario of this video. In this scenario, let's talk about one-to-one NAT. To put it to a simplified way, one-to-one NAT means, okay, you have multiple public IP addresses and you want to map each IP address to a internal private server. All the traffic to and from a given public IP address will be translated to a specific internal private server. For example, in my lab environment, for the primary WAN part, I have these 4 IP addresses configured, and I want to keep the main IP address, the IP number 1, untouched, but for the other 3 IP addresses, I want to map them to 3 different internal servers. So let's see how we can use NAT rules to achieve that. For these 3 servers, I already configured web servers, so internally the web servers work for all of them. But if now, based on the default configuration, if I try to visit the 3 IP addresses from the WAN part, let's see what we can get now. So from the Apple machine, which is in the WAN part, let me launch a browser. Then let me try to visit one of the IP address. For example, this .2.192. You can see it will try and then it will fail at the end. Why? Because the 3 servers, they are not exposed to outside world yet, right? Then let's see how we can start the configurations. First, of course, we need to configure DNAT rules because we want the outside world to be able to access our internal servers, right? So for the DNAT rules, I just created 3 new rules. Let's look into them. For example, the first one. For this one, I want to translate the first destination, the .2.192 IP address, to the first internal server, which is in default network. And for the second DNAT rule, I want to translate the .2.193.1 IP address to the second internal server, which is in VLAN 10. And for the third DNAT rule, in the similar way, translate the .2.194 IP address to the third internal server, which is in VLAN 20. Okay, so now all the 3 DNAT rules, they are active. Now let's see whether from outside we can visit the 3 individual servers. Let's try the .2.192.1 IP address. Yes, it works. See, the server is from default network. Then try another IP address. Okay, successful. And this time is from VLAN 10, from the second private server, right? Then try the last IP address. Okay, this time is from the third internal web server. Okay, for this direction, from the WAN, visit internal LAN servers, all the 3 rules work already. However, we are not done yet. Let me show you what I mean. So from the Apple computer in one part, let me run a iPerf3 server. The reason I use iPerf3 is to simply show you the IP address. It's not really for performance testing. Okay, then from the first internal server, let me run the iPerf3 in client mode against this Apple server. See the source IP address shown in the Apple machine side. It's .2.191. If you check the diagram, it's the first IP address, which is the main IP address. It's not one of the 3 IP addresses we want to use in this video, which means the mapping for the first server doesn't work for this direction, from internal to external. The other 2 servers also don't work. So then how we can make it work? We need to configure SNAT rule. We are only halfway at this moment. So let's see what's the SNAT rule we need to configure. I have configured these new SNAT rules. Let's check them one by one. The first one, it will translate from first internal server's IP address to this .2.192 IP address. So this time the translation direction is from internal to external, right? Exiting the one part. Then for the second rule, it's similar. This time it's for the second internal web server. Then the third rule is for the third internal server. So now all the three new SNAT rules, they are active. Let's try the same IPv3 operation again. See, this time the IP address changed. From the Apple machine, we can see the source is .2.192. That's exactly what we want to achieve because we want to map the first server to this IP number 2, right? This time, this direction is successful. Then in a similar way, we can validate the other two servers. From the server 2, let me run the same IPv3 command. Okay, the IP address is shown as .2.193, right? Try the same thing in the third server. Okay, successful. It has the other IP address, the .2.194. So by using the SNAT rules and DNAT rules together, we successfully achieved the one-to-one NAT for the three public IP addresses for the gateway. We map them to the three different servers inside our private networks. Okay, this ends the third scenario. We are done with this video. Thanks for watching.